Okay, these are the notes for Chapter 1, Section 2. Let's go ahead and start with Part 1. We're going to start with really simple here. We're going to start with kind of just talking about addition, expressions, a little bit of algebra. All right, so we're going to get into this. We've got with addition, the numbers being added. What we call those are called add-ins. You might not have known that. Yeah, but those are called add-ins. How you say it? Looks like it's got the word add in it, ADD. I don't know if I wrote that very well, but yeah, add-ins, okay? And that's when you're adding those numbers up. Obviously, the when you add up add-ins, you get a sum, S-U-M. All right, and when we talk about algebra, all right, we talk about a lot of times there's variables that are involved. So a variable is represented by a letter, right? We use typically in algebra, you see an X, right? Or a lot of times you see N, but really it could be any letter in the alphabet, right? It could be anything. And this part right here is an algebraic expression. So an algebraic expression, write that down in your notes. You got that. It's kind of important. That's a combination, where you have variables and numbers and some type of sign, like typically plus sign or minus sign that's connecting those terms in the expression that we put together. Okay, so what we have here in this example is we have a bunch of phrases and we want to kind of just translate that. It says translation into symbol, but more or less we're going to kind of translate it into an expression. We're going to translate it into a number or a numerical, or in other words, an algebraic expression. So the first one there is 6 more than 9. Well, that's not really algebraic, but that 6 more than 9 is going to be, more than is indicating addition, right? So that's going to be 9 plus 6, 6 more than 9. Although we could switch that. We can kind of swap those and do 6 plus 9 because it's the same thing. All right. The sum, all right, the sum that indicates addition of some number. Okay, now that doesn't mean just make up a number. We don't know what the number is. So in algebra, when we don't know what the number is, we make it a letter, we make it a variable. All right, so the sum of some number and 7. So that is going to be, I'm going to use n for that number because we don't know what it is. And 7, so we're going to do plus 7. And same thing with as like the other problem there. That could very well be switched. We could make that 7 plus n, and it wouldn't make a difference in terms of the sum. All right, the next one there is 4 increased by 2. All right, that's pretty straightforward. 4 increase, so plus 2, right? Now I could answer that, the first one as well, and this one. We don't need to. We're just kind of writing it out as a numerical expression or number expression here, or an algebraic expression. 3 added to a number. All right, 3 added to a number. Again, we don't know what the number is. When it says a number, don't just make up a number. We don't know what it is. I mean, yes, you're probably right. It could be any number. Like you could write 17, or it could be -8. But that's not really the point. The point is that we don't know what the number is. Therefore, we should assign a variable to it. Like I'll use x this time. So x plus 3. And then right here, same thing, 1 plus a number. So 1 plus, I'll put C. All right, and that's it. All right, this next part right here says translate each phrase using numbers and variables. This is kind of what we were doing. So 8 added to some number. Well, we don't know what that number is. So we're just going to make up, I'm going to say the number is D plus 8, just like that. That's all there is to it. All right, 7 more than a number. All right, we don't know what that number is again. These are kind of seeing a theme here, right? These are very easy. So 7 more than a number. So I'm going to make n the number, so plus 7. All right, now in part 2, we get into just a few number properties here, which are kind of important. The first number property that we're going to talk about is called the identity property. All right, so now there's a few identity properties, but we're going to call this the identity property of addition. And for the identity property of addition, is basically when 0 is added, nothing changes. Kind of a simple property. When you really think about it, it's nothing really to it, but that's what we're basically saying. 17 plus nothing, right? 17 plus 0 is 17. So that doesn't change it, right? That's the identity property. That's typically what, when you're dealing with the identity property, there's another one, identity property of multiplication. But we're always thinking about like what can be put with that number so that it does not change, and for addition, it's 0, right? So as long as you're adding 0, nothing changes. So this is really, really simple. So negative 250, right? Plus 0, guess what that is? That is still negative 250. Okay, it's unchanged. That is the identity property. It's a very simple property. All right. All right, so the next property is this property called the commutative property. All right, and commutative property is kind of a unsung, kind of often forgotten about number property because it's just, I find it pretty useful, and we don't necessarily refer to it as a commutative property a lot. A lot of times we just kind of, we're using it perhaps, we don't really necessarily know that it's called a commutative property. But what it means is that the order of the numbers can change without changing the sum. And so what that means is like take a series of numbers. Let's say we have like 13 plus 9 plus 7 plus 11, something like that. Okay. So, which is not, not necessarily super difficult order of numbers that you have to add. It's probably not going to burn out too many brain cells working that out. But if you change the order of it, you can kind of make it a little bit easier on yourself, and I kind of intentionally made it this way. But so what I'm thinking is like, what if I changed it like instead of 13 plus 9 to 7, I did 13 plus 7? Because I noticed that 13 plus 7 are, those numbers go well together because they make 20, So they make 20 and so does 9 plus 11, right? So plus 9 plus 11, so now I'm looking at this as 20 plus 20, which is a really easy sum, to work out mentally. And that's kind of the point of the number property. Well, at least this number property is to kind of be able to, be able to process these out in an easy way. It doesn't always have to be super, easy, like just making 20s, or a lot of times you're making 10s or hundreds, or or just putting numbers that you just are more comfortable with. It doesn't matter. But commutative property, a student told me this years ago, but if you ever want to remember the name of it, commutative, I'm not going to write it all out, but this person said, oh, commutative begins with the letter CO, and they just thought, oh, that's change. They just thought, oh, CO, change order. That's a good way to remember it, if you're ever like on a test or something. You're like, I don't remember, because they're really easy to forget. You're like, what is even the commutative property? But it's a property where you change the order. All right. And by the way, this is the commutative property. We're talking about a lot of properties here of addition. All right, I'm going to abbreviate that. But that's the commutative property of addition. A little bit of a mouthful there. And this last property that I'm going to show you is called the associative property of addition. So you have the associative property of addition. And what that states is that that involves changing the grouping, the grouping. And what does the grouping? The parentheses. Okay, so it involves changing the grouping, but it does not change the sum. The overall value of the numbers don't change. Okay, so you can change the sum of them. All right, let's notice this. Notice I'm really laggy here. I'm sorry about that. All right, let me show you an example here. So the commutative property of, or the associative property of addition kind of looks like this. You might have like 7 plus 9, then put this right here, 9 plus 14 equals 7 plus 9 in parentheses plus 14. Oh, I just thought of something. I think I just messed this up. Sorry about that. I wrote the wrong thing here. The associative property of addition involves changing the grouping, but not changing the order. That's what I should have written there. Sometimes I don't know how I arrange my notes, but yeah. So it involves changing the grouping, but not changing the order. Okay, so and you can see that with the way I wrote it. So you'll notice here, I have a 7, 9, and then a 14. And it's same order here, 7, 9, and 14. What did change, however, was the grouping. Right here, we've got 9 and 14 in a group, and right here, 7 and 9 are in our group. So the grouping indeed changed, okay? So that's the associative property of addition, okay? You're changing the grouping. You're changing how the numbers are associated. That sometimes doesn't really help people, but it does help. I think that commutative property, that CO, definitely helps you kind of distinguish between the two. Anyhow, all right, let's go to the next page, which is part 3, evaluating. Okay, let's talk about how to evaluate expressions. So when evaluating an expression, the variables, so when evaluating an expression, substitute the variables with their corresponding values and solve. All right, so what we're going to do here, is we've got an expression, x plus y plus 10, all right? And we're just going to put in those values that x and y are equal to. So for the example A, we've got 13 equals x equals 13, and y equals 24. So we're going to put those, I usually do this when I'm showing people how to evaluate. So if this is totally new to you, so we're going to put in 13 for x right there. We're going to put in 24 for y, and then just solve it. Just kind of put it together. So 13 plus 24, that's easy, right? That's 1,000, right? No, that's not 1,000. That's 37, right? That is 37 plus 10 makes 47. All right, same thing. We're just going to evaluate here. We're going to put in 18. Do this, 18 plus 9 plus 10. All right, 18 plus 9 is 27. 27 plus 10 is 37. See, that's pretty simple. Pretty simple stuff there. All right, and then right here, we're not really evaluating anything. We just have a bunch of numbers that just need to be added up. So if you're not using a calculator, which you shouldn't have to on this kind of problem. You can just line up the place values, right? Line them up and then add them up. Add them up. So you got, so 3 plus 6 is 9. And then 9 plus 3 is 12. So you put the 2 and 12 right there, and you carry over the 1. So this is called a regrouping. And then 1 plus 7, that's 8. 8 plus 6 is 14. 14 plus 5 is 19. So put the 9 down, carry over the 1. And then 1 plus 4, that's 5. 5 plus 8 is 13. So there's your answer, 1,392.